So the next question, a pump is used to increase the water pressure from 70 to 700 kilopascals between the inlet and the outlet of the pump. Water first enters at 15 degrees Celsius through a 1 centimeter diameter opening and leaves through a 1.5 centimeter diameter outlet. The mass flow rate through the pump is 0.6 kilograms per second. Compute the velocity of the water at the inlet and outlet. Will these velocities change significantly if the inlet temperature is raised from 15 degrees Celsius to 40 degrees Celsius? Okay, let me just open it up on the other screen here. Great. So first things first, we go to the property tables and we get the specific volume of water. Because remember, specific volume and density, and we need density when we talk about mass flow rates, they're really giving you the same information. All right, it's basically how much stuff you can pack into a certain area. And if you flip that upside down, you get specific volume. But if we go to the property tables, they only show specific volume, so that's what we're going to work with. So if we go here, we'll see that m dot, being the mass flow rate, is rho AV. In other words, it's A volume over specific volume. Okay, we want to find the velocity. Sorry, I made a mistake there. It's a velocity, not volume. Not sure how to erase this. Sorry about that. So it's AV, where V is the velocity over the specific volume. We're told in the question that m dot is 0.6 kilograms per second. And at the inlet, let's start at the inlet. We'll do it both at the inlet and the outlet. Starting at the inlet, we're told that we have a 1 centimeter diameter opening. So the area at the inlet is pi over 4 diameter, 0.01 squared. And this is all multiplied by V divided by the specific volume. And if you look at VF, because we're assuming for a compressed liquid and a saturated liquid, VF doesn't change much, you'll see that the specific volume is 0.001001 meters cubed per kilogram. If you calculate all of this, if you isolate V specifically being the velocity, you'll find a velocity of 7.647 meters per second. So that answers that. But we also want to know the velocity at the outlet. So what changes at the outlet? Well, the water is still at the same temperature, so this does not change, all right? The mass flow rate we said from the last question, and in general, there's no way we can just change the mass flow rate if nothing's going on in the middle, right? What goes in comes out. So this hasn't changed. The only thing that's really changed is the size of the opening. So if we just recalculate the exact same thing, we recalculate V, but this time we use a 1.5 centimeter opening and the same specific volume. We'll end up with a velocity of 3.3987 meters per second. And you can see clearly that this is significantly smaller than this. And this is something that you'll come to learn a lot more in fluid mechanics, where you see that as the area of some passage increases, the speed of the flow through it decreases. And it all has to do with keeping the mass flow rate constant. Because if both the speed and the area increased, it doesn't really make sense, because that means there's more mass leaving than there is coming in, and we know intuitively that makes no sense, and vice versa. So the point is, when the area of anything goes down, the velocity goes down. The velocity goes up, and vice versa. So this is just something to keep in the back of your mind. If we saw that this was somehow bigger, we'd know we made a mistake somewhere. Okay, now the question also asks us how this changes if the temperature is a bit higher. And if we look at the property tables at 40 degrees Celsius, the new specific volume is 0.001008 meters cubed per kilogram. So just looking at the inlet even, if we take this guy and replace it here and recalculate V, we will get V equals 7.7006 meters per second. And we can see that clearly it's different, but it's not much different. And that's because it's still liquid water. At it's very incompressible. It's very difficult to change the density. So even when we go to a different temperature, we see that the specific volume and therefore the density is extremely, extremely close to one another. So naturally, all other things being equal, the velocity will barely change.